Okay, welcome sa video natin, 'no. This time proceed tayo sa second practice problem natin. A simply supported beam with overhang is loaded with a uniformly distributed load. W equals 10 kilonewton per meter and the concentrated load P equals 15 kilonewton as shown. So L1 daw natin is 3, L2 is 2. Using double integration method, so unang pinapahanap sa atin, how far from the left support in meters is the location of the maximum deflection. Then, what is the maximum deflection? And number 3, what is the deflection at the free end? So, gaya ng una, no, ang first step natin dito would be to calculate yung ating, or yung, to draw muna pala, no, yung ating free body diagram, no, including yung ating elastic curve. So, meron na tayo niyan dito sa baba, no. Drawing na natin yan. That would be this one, no. So, meron tayong 15 kilonewton na load concentrated, then 10 kilonewton per meter na uniform load. And ito yung tentative natin na elastic curve, no. So ina-assume natin yung delta max natin or maximum deflection natin would be somewhere near the left support, no, bago siya mag 3 meters. So random assumption lang yan. So ngayon, calculate muna natin yung ating support reactions, no. So unahin natin si left support, RL. So sum lang tayo ng moments. Or no, unahin pala natin si right support. No? So sum tayo ng moments along the left support equal to 0. Ayan, so meron na tayong right support reaction, no? 365 over 6 kilonewtons. Now, calculating naman si left support. No? Si left support reaction, gamit na lang tayo ng summation of vertical forces natin. No? Equate natin yan sa 0, setting upwards positive. So ayan na, no? Nakuha na natin si RL na 205 over 6 kilonewtons. Now, meron na tayong left support. Meron na tayong right support. Now, calculate na natin ngayon or form na tayo ngayon ng moment function natin using the Macaulay Functions. So, set lang tayo ng origin natin. Set natin yung kaliwa. So, left to right yung takbo natin. No? So, we have mx equals una nating may encounter yung left support. So, that's just 205 over 6 x. No? So, the first degree yung point load natin. Tapos dahil nasa origin lang yan, no? So wala na tayong brackets. Minus, sunod natin may encounter si uniform load. So 10, di-divide natin yan sa 2. That would be 5. Or lagay na rin natin. You have 10 over 2 times x squared. Again, sa origin din yan. So wala na tayong brackets. No? Minus, sunod nating may encounter, no, is si 15 kilonewton downward. No? So 15, now mag-o-occur yan at x equals 3. No? So x minus 3 raised to 1. So finally, si right support yung may encounter nating huli. That would be plus 365 over 6 times x minus 6 raised to 1. So compared sa problem 1, no, hindi natin kinonsider si right support kasi nasa dulo siya. Pero itong si right support dito, no, hindi siya nasa dulo ng beam, no, kasi may overhang tayo. So magpa-positive ito at some point, itong x minus 6. Hindi natin siya i-ignore. Now, isusulat lang natin yung ating differential equation. No? You have EI times d squared y over dx squared equals moment natin. No? So, i-apply na natin yung double integration method natin. So, for the slope natin would be EI times theta x equals, okay, so na nakuha na natin yung expression natin for theta. Again, meron tayong C1 dito na integration constant. Now, i-integrate naman natin itong buong ito to get yung ating deflection equation. Okay, so meron na tayong deflection equation, no? Excuse me. Now, check natin yung boundary conditions natin, no, para ma-evaluate natin si C1 at si C2. Now, at the left support, meron tayong roller dyan, no? Bawal yan mag-deflect. So, x equals 0 natin. So, at x equals 0, yung y natin 0 din, no? Kasi bawal mag-deflect sa roller support. So, applying that, we have 0 equals, ito 0 lang ito, kung 0 si x. Ito rin, 0 lang din. Now, ito, 0 minus 3 is negative. Now, for Macaulay functions, any negative would be 0. So, 0 lang din ito. Similarly, 0 minus 6. This is just negative. So, magiging 0 lang din yan. So, ito rin, C1x, 0 lang din yan. So, finally, we're left with C2 equals 0. So, ganun lang kadali. Now, next, titingnan natin yung beam natin. No? At x equals 6, meron tayong pin support. So, 0 din yung deflection doon. So, we have a 0, or no, at x equals 6, y equals 0. So, ili-layout natin yung equation natin. No? So, 0 equals 205 over 36 times 6 cubed minus 5 over 12 times 6 to the 4th minus 5 over 2. Now, 6 minus 3 is positive. So, kokopyahin lang natin yung value niya. No? 6 minus 3 is 3 lang, no? So, 3 cube lang yan. Plus 365 over 36. Now, this is 0, no? 6 minus 6 is 0. So, pwede na pala natin i-disregard yan. Purahin na natin yan. Plus, we have C1 times 6. So, 6C1. Yung C2, disregard na rin natin kasi 0 lang naman yan. So, solving for C1, we have negative 415 over 4. So, ito na yung C1 natin, ito na yung C2. Pwede na nating i-rewrite yung ating slope and deflection equations. Okay, so nare-write na natin yung ating slope and deflection equations. Now, ang pinapahanap sa atin sa una, no, would be the location of the maximum deflection. No? Yan. So, gaya nung sa first problem natin, no, at maximum deflection natin, so at max deflection natin, theta natin would be 0. So, 0 yung rotation natin at maximum deflection. So, applying that, no, i-0 lang natin ito. So, we have 0 equals 205 over 12 x squared minus 5 over 3 x cubed minus, now, check natin yung beam natin muna pala, no? Now, yung assumption natin sa maximum deflection, no, is mag-o-occur siya to the left, no, of x equals 3, no? So, hindi siya abot ng x equals 3. Kung yun yung case, no, na hindi aabot siya ng x equals 3, itong x minus 3 natin would be negative. And itong x minus 6 natin would be negative din, no? So, effectively, itong dalawang ito ay magzi-0 lang. So, i-disregard na natin sila, no? So, diretso tayo with negative 415 over 4. Now, solving this, okay, so nakuha natin x equals 2.913 meters. No? Ang assumption natin, less than 3 siya. So, na-satisfy niya 'yun. Ibig sabihin correct. Ibig sabihin tama yung assumption natin na hindi siya aabot ng 3 meters yung maximum deflection 'no. So, ito na yung sagot natin for item 1. Mag-o-occur ang ating maximum deflection at 2.9 meters from the left support. Now, calculating natin 'no, yung maximum deflection natin, we have y equals or EIY equals 205/36 times 2.9 cube, 913 no, 913 cube minus 5/12 times 2.913 to the fourth. Again, 0 na ito, 0 na rin ito, so diretso na tayo dito 'no. Minus 415/4 times 2.913. Okay, solving for y, we have 191.468 over EI. So ito na yung ating sagot for item 2. Now finally, ang tanong sa atin, what is the deflection at the free end 'no? Now at the free end, that's x equals 8 'no. Sulat natin at x equals 8. Yun yung free end natin 'no. So plug in na lang natin siya dito 'no. So we have EI times y excuse me. We have 205/36 times 8 cube minus 512 times 8 to the fourth, 5/12 no? Times 8 to the fourth minus 5/2 times 8 minus 3 cube no. So no, normal parenthesis na lang tayo dyan plus 365/36. Ito rin no, normal parenthesis na lang minus 415/4 times 8. Now, evaluating this, we have 147.5 over EI. So, ito positive, ito pala ay negative, no? So, ibig sabihin, positive yung deflection natin at the free end, no? So, tama yung assumption natin na aangat siya. So, i-box lang natin yung answer natin, no? Okay. So, ayun, nakuha na natin, no? Na-evaluate na natin yung tatlong hinihingi sa ating values sa problem na ito. So, ganun lang kadali i-apply dito yung ating DIM and yung ating Macaulay Functions. Mas madali siya compared kung magse-section tayo, yung susundin natin yung traditional solution, no? Tatlong section ang gagawin natin diyan. So, isa, dalawa, tatlo. Tapos, tatlong integration ang gagawin natin for the slope and tatlo rin for the deflection mismo. So, ilang integration yun, nakakapagod. Pero ang ginawa natin dito is Macaulay function lang tayo. Isang beses lang tayo nag-integrate for each ng slope and ng deflection. So, talagang mas nagpapabilis yung Macaulay functions natin. So, that ends yung second practice problem natin. Meron pa tayong isa na practice problem. Doon, titingnan naman natin yung application niya to statically indeterminate figures.